Alright guys, this is the lesson after spring break, so if you want to get ahead, you can continue. If not, then you can take a break and then look at this one after spring break. Alright? Just let you know that this is the last lesson for the exponential functions. After that, we'll be moving on to logarithmic functions. For this lesson today, we are going to look at exponential functions and use it to make predictions about growth and decays. In the last few lessons, we have been talking about exponential functions in this form. Y equals to abx. Okay, a is the initial value. If it is in this form, then the a value would give you the y-intercept, and b is the base, and then x is just function. Okay, now we are going to move on to this one here. If you look at this, hope you are not intimidated by this one here. These two are literally the same thing. Look at this, a, b, x, a, b. Instead of talking about just a function of x, there is more content for x. So which is t over p. We'll look at what that means in a second. Alright, so I'll just write it down here. Recall the formula we have been using so far, which is abx. Now we can look at which one is which here. Okay. So if you look at this formula here, as I just showed you, this is on your formula sheet, so you don't have to memorize that. It's just this one that's not on the formula sheet. But like if you look at this on the formula sheet, you just have to replace this exponent part by x. That's it. Okay, so now for today we will be focusing on this formula here. So what's y? The final amount, whatever you have. Okay, a, the initial value, in this case is the initial amount. B is the multiplication or growth factor, which is this one here, or in the previous context we call that the base. So this one here, you may call that the rate of growth or rate of whatever. The time here, the t here is the time elapsed, so how long it takes something to happen. So just like this, how long it takes for the multiplication factor to occur. And then the p on the bottom is the amount of time taken for a specific situation or event. So this is the total amount of time. Alright, and they may trick you on the diploma exam like in science and chemistry, so make sure that whatever time we talk about here and here, they must be of the same units. Hours, hours, days, days. So these two must be in the same unit so that you can cancel things out, simplify this, and so on and so forth. Alright, so here I have a couple things to add on for this, some wording that may help you. So what kind of wording you may see? So you may see the term doubling, for example, bacteria, and you may also see tripling, sorry, okay, and you may also see some exponential decay. For those of you who took the Chem AP, you are in the upper hand, so reduce, or not just Chem AP but also in Physics 30, so reduce to half, like the half-life thing that you learn in Chem AP and Physics 30, etc. So if you see questions involving these kind of wording or these kind of concepts, so most likely you'll be using this formula. Alright, so let's work out our first example using the new formula. So a strain of bacteria triples. So if you look at this, this is the buzzword. Alright, every 25 hours, a petri dish contains 120 bacteria. How many bacteria in 4 days? So that's the buzzword, as I just said. So you should be thinking of using this formula instead. Alright, so let's write that down. Y equals to A, B, X, not X, but instead T over P. So all we have to do is plug the numbers in. And if you look at this, the question is asking how many bacteria in 4 days. So that means we don't know Y. Do we know the initial amount of bacteria? Yes, we do, 120. That's the initial amount. B, what's B? I'll give you a few seconds to think about. You guys are English speaking, so I hope you all know that triple means 3 times more. 3 times more. Now, if you look at T and P, as I mentioned on previous slide, we like to trick you. If you look at this, it talks about 25 hours for tripling, and then here we talked about time. So you have two options. Either convert the tripling time here from hours into days, or convert the total amount of time here from days into hours. So if there are no objections, I would be converting this into hours, and hopefully you have the common sense and know that there are 24 hours a day. So if you look at this here, so 4 days, so you take 4 times 24, that gives you 96 hours. Alright, so now our total time would be 96. Again, as I mentioned before, this is not science, so you don't have to write down a unit here at this point, but make sure you write down any units applicable, if applicable, at the end. Okay, so the total time is 96 hours, and then the tripling time, the time for the event to happen is 25 hours. Okay, plug that into your graphing calculator or any calculator. Alright, since this is our first example using this new formula, I'll quickly walk you through here. So if you look at this, you can do 120 times 3 raised to the power of, make sure you use brackets, 96 divided by 25. Alright, enter. If you want, you can also take advantage of a fraction function if you're using the TI-84 plus CE or more advanced model or newer model. So 120 times 3 raised to the power of, go to math here, and then move the cursor to the left to fraction, pick number 1. So now you can put down the numerator and denominator. Numerator 96, denominator 25, enter, you get the same answer. So 8,153. 8,153. I hope you have common sense to realize that even though for the answer we just got from the calculator is in decimals, but because we are talking about how many bacteria, so we are rounding it to the nearest whole number. Okay, let's move on to part B. A petri dish has 950 bacteria. How many bacteria were there 3 days ago? So this is not the initial amount. This is the final amount after 3 days. So again, let's start off with writing the equation first. So y equals to AB raised to the power of T over P. Okay, now let's plug the numbers in and set up a question. So my final amount is 950 bacteria, right? And the question was asking how many were there 3 days ago. So that means the question is actually asking the initial amount A, we don't know. And then the B, this is related to the previous part A. Okay, so tripling, so that means our multiplying factor is 3. And again, if you look at this, the bacteria triple every 25 hours. So, and in this case, we're talking about days here. So again, you can either convert the days into hours or hours into days. So 3 times 24 gives you 72 hours. Alright, so that means our total time is 72. And then the time it takes the event to occur for tripling in this case is 25 hours. So like that. Alright, so in this case, this is the only thing we are looking for, so that's easy, simple math. So divide both sides by this. So 950 divided by 3. Again, I would suggest you guys you write down the brackets to avoid confusion. Raise to the power of 72 over 25. So this time I'm not going to show you. If you plug this into your calculator, you should get a decimal. And again, because we are talking about how many bacteria are there, so we round it to the nearest whole number. So if you plug that into your calculator, you should get, after rounding, 40. So that means we start off with 40 bacteria. Okay, have a quick look at this question. So you might pause for a few seconds and then try it yourself. Alright. Okay, so assuming you have done something, hopefully. Now, if you look at this, we are talking about half-life. For those of you who are in Physics 30 or Chem AP, I'm sure you have done this. Or at least something like this, very similar to this. Anyway, if you don't have those experience, never mind. Alright, so now, if you look at this, let's set up a question. Of course, as you would expect, I would start off by writing out the equation first. A times B raised to the power of T over P. Okay, now if you look at this, the question is asking how much of the sample remains. So that means after a certain time, how much would be remaining. So that means we are looking for Y, because we know how much we have initially at the beginning, so 215 grams. So again, this is math, not science, so you don't have to write down the unit in the steps here. So if you want, you can still write down grams here, but I'm not going to. So, and my B here, you guys are English speaking, so half-life, so that means every period, or after every period, there would be only half remaining. So that means my B, the base, or the multiplying factor would be 1/2. Or if you are more comfortable with a decimal, you can write down 0.5 here. That's totally acceptable. Alright, so and then T over P. So same thing here. If you look at this, our time period are in 2 different units. So one is hours, one is days. So same thing, you can convert the days into hours or convert hours into days. And again, I am going to convert the days into hours. So 32 times 24. Alright, so that gives you 768 hours. Okay, so that means the total time T would be 768, and then on the bottom, the time period for this type of events to occur, which is reducing to half, is 40. Now all you have to do is plug that in, quickly plug that into your graphing calculator. If you punch this into your graphing calculator, you would see something like this. Okay, so what does that mean? This means times 10 raised to the power of -4, right? .57. You can write down 3.6 if you want. The question did not talk about rounding, so times 10 raised to the power of -4. In this case, there is a unit attached. So make sure you write down the units at the end, or you will be losing marks on the diploma exam. Alright? So I know some of you say, how come the calculator would do something like this, even though you may not have changed your calculator setting into scientific notation because it is such a small number, just that you know, right? And if the question is asking for something like a dot, we'll talk about this in the future if there's any diploma exam, a dot bc times 10 to a negative d. I'm sure some of you have seen this in science, physics, and chemistry in particular. So in that case, it would be more beneficial to write it in this form so that you can write down your answers a dot b c times 10 to the negative d. Or if you don't feel comfortable with this kind of things, or if you want to see how small this number is, I'm sorry, I don't know how to do this on the TI calculator. So you might want to ask some other people. So manually, you can just move the decimal 4 spots to the left. So if you do so, you will end up with 0.000357 grams. Okay. Okay. If you don't trust me, you can punch this into your graphing calculator, and let's see what happens. 0.000357. So let's do this. 0.000357. Enter. It gives you the same thing. Well, I know not exactly the same because we did some rounding, but look at this. 3.5 ish times 10 raised to the power of -4. Alright? Alright? So I hope so far so good. Next question. There is support of 3000 radioactive blank. Well, if I don't know what you want to put down, be creative. I don't know what you want to put down, but anyway, if you want, put down chain here, radioactive chain. Alright, after 3 hours, there are 48,000. What is the doubling period? So, this is the buzzword. So what does that mean? That means we should be at least knowing that this formula to be used. Okay, so now a few seconds, quickly write down those numbers. Okay, so if you look at this, we know after 3 hours later there are 48,000, so that means the final amount is 48,000. And then in this case was my A, the initial amount, 3,000 here, 3,000. And then what is my P, sorry, my B multiplication factor thing? If you look at this, the question talks about doubling. So that means after a specific time period, you get double the amount. Like 1 becomes 2, just like bacterial growth. 1 becomes 2, 2 becomes 4, 4 becomes 8, 8 becomes 16, so on and so forth. Okay, raised to the power of, in this case, this is the time required for specific event. So it is not, this is not, this is for the P. Okay, so the total time here is 3 hours. And then for the doubling period, it would be P. Okay, so that means whatever answer we end up with, since this is in hours, therefore this would be in hours as well. Okay, what you might want to do now is to simplify this, of course. So divide both sides by 3,000, divided by 3,000, gone, gone, and then we end up with, on the right hand side, 2 raised to the power of 3 over P, and then left hand side, 48,000 divided by 3,000, that gives you 16. So if you recall the previous lesson we did on exponent laws, then you'll probably remember that we talk about converting some numbers into common base. In this case, unfortunately, you have not learned the technique yet to solve this algebraically directly. We are still solving this algebraically, but we cannot. There's nothing you have learned that would help you solve P directly. So that means we have to do it the linear way, i.e. by making sure that we have a common base on both sides. So in this case, hope that's obvious that you have a base of 2. So let's rewrite 16 in terms of base 2. Okay, so 2 raised to the power 4. You call triple 2, that gives you 16. And then right hand side, I'll put the brackets so that the two sides look the same. Okay, now we have the same base on both sides. So what can we do? We can drop the base. So that means 4 is equals to 3 over P. If you do some manipulation, in this case, you can cross multiply. Okay, so divide. Okay, divide. Sorry, just cross multiply. So 4P equals to 3. Just free up more space. And then divide both sides by 4. So that means P is 3/4. Not just that, as I mentioned earlier on, because we are using the total time in hours, so that means this answer is in hours. Okay, just that you know that maybe like science, they would trick you by asking you to convert the amount of time, in this case, from hours into minutes. So they may not even say convert this, they may say what is the doubling time in, or doubling period in minutes. Then you better be aware of that. So again, use common sense. Each hour has 60 minutes. So if you take this 3/4 times it by 60, that should give you 45 minutes. So you can also say that the doubling period is 45 minutes. Okay, let's keep going. So I'll just volunteer myself. Ching. Okay. So the question is, how long would it take to reduce a blank to 25% of its original radioactivity? So that's the buzzword. All right. So that. All right. So obviously we are going to use this equation once again. So now I'll give you a few seconds. Think about which one goes where, how to fill in this and what you are looking for. So if you look at the question is asking how long. So that means we are looking at the T. That's the total amount of time, not P, because we already know that the half-life, the time for a specific event in this case, is 8.2 days. But when you look at this, do we know the initial amount? No. Do we know the final amount? No. So how should we approach this question? All right. So I'm going to pass on a new technique to you. In this case, we know one thing for sure. The initial amount, whatever that is going to be reduced to 25%. Right? So there are two ways you can set up this question, or you may call plug in the numbers. So first option is we assume the initial amount to be, let me just use a different color. Initial amount to be 1, and then after reducing to 25% of the original amount, that means our final amount would be 0.25. Or if you feel more comfortable with the percentage stuff, then we can assume this is option 1. Option 2, the initial amount to be 100, and then after that it was reduced to 25% of the original amount, 25. So if you look at this, even though the initial amounts are quite different, final amounts are quite different, but then if you look at this is only 25% of the original amount. This is also 25% of the original amount. So mathematically speaking, it doesn't matter, but keep it consistent. Either do it this way, set the initial amount to be 100, or set the initial amount to be 1. So I'm going to use the first option here, initial amount to be 1, and then after that the final amount is 0.25. If you look at the PDF file that I posted on Decay already for the notes, not the video one, then you'll see that this one is being used. Then you can check that, doesn't matter. Okay, so I'm going to prove that to you. So my final amount here is 0.25. 0.25. My initial amount would be 1. Alright, 1. And then what's my B? We're talking about half-life here. So after every time period, we would end up with only half. So it doesn't matter if you want to put 1/2, that's fine. If you want to put down 0.5, that's equally fine, because 0.5 and 1/2, they are exactly the same. Okay, so in this case we are looking for T, so we don't know that. What's the P? 8.2. So what does that mean? Whatever time we figured out, the total time, it will be in days. Alright? So if you look at this, there's not much we can really do. So 0.25, other than doing the calculation here. So 1, you can just leave that out, equals to 1/2 raised to the power of T over 8.2. So if you look at this, what can we do? Of course, we convert them into common base. So let's convert this. I would convert this into fractions. Okay, if you want, you can convert this into decimal, but I personally think that converting this into fraction would be more obvious, easier to see. So okay, so 0.25 is the same as 1/4 equals to 1/2 T raised to the power of T over 8.2. So now how can we make a common base? You either convert the 1/4 into 2, or convert the 1/2, either convert the 1/4 into 1/2, or convert 1/2 into 1/4, so that you have the same common base. So give you a few seconds to think about that. For those of you who think you can convert the 1/2 into 1/4 by squaring it, you're correct. But then the problem is you screw up this whole question. You actually change the question, because if you square this, that means you have to square the other side. It doesn't work out. Okay, so that means we have to convert 1/4 into 1/2. How can we write a 1/4 as 1/2 square? That means 1/2 times 1/2, that gives you 1/4, right? And the other side is still 1/4. So in this case, I don't have to like square or taking the square root or anything. I just rewrite 1/4 as the square of 1/2. Okay, and then let's finish this. Raised to the power of T over 8.2. Now, as you can see, they have the same base. So what can we do? Drop the bases. So that means the exponents should be equal to each other, which is 2 equals to T over 8.2. If you can figure out this new thing here, and then a little bit tricky math here for converting the bases, then this question is not that bad. So Last step, cross multiply. So that means T is 2 times 8.2, which is 16.4. In this case, we talk about that. We use the 8.2, or the 8.2 is actually in days, so that means 16.4 days. If you don't feel comfortable to write this way because your variable is on the right hand side, you can write this way, 16.4 days. Alright? Good. Okay, last two questions. Alright, so read the question first. So question is, what will the population be in 17 years? So that means we're looking what happens after 17 years. So in this case, with that said, that means we'll be using this formula again, y equals to a times b raised to the power of t over p. Alright, so that's easy. We know we are looking for the population in the future, so this is the final one, so that means we should know all this. So let's plug in the numbers. A, the initial population or the current population, 8,980. Okay, you can put the bracket, it's up to you, or you can just leave that. And then if you look at the growth rate, in this case, like not doubling, not tripling, not half-life, so that's 7%. And then raised to the power of the total time is 17 years. 17 over, in this case, we are talking about this happens every 2 years. So the time period for this event is 2 years. Okay, plug that in. Congratulations, you just screwed up. Think about why. Alright, so some of you probably figured that out. We cannot simply write 7% as 7, so we have to divide it by 100. So that gives you 0.07. So plug that into your graphing calculator and look at the answer. Does that make sense? If you look at the question, it says growing. If you plug this into your calculator, I did not even bother to do that because we know for sure, I know for sure, not you, we are going to get a very small number, so it doesn't make sense. What's wrong? At the beginning of the unit, when I first started, I talked about an interest rate question. So let's do it on the side here. Let's say if you have $100 and you put into the bank with an interest rate of 5% per year, how much would you get a year later? So you take this amount, times it by 1.05. So this will take care of your initial amount and then the growth rate or the interest rate. And here, with that said, that means you should be writing down 1.07. Okay, now everything should work out. Plug the numbers in. Okay, you should get 15,960 people. Alright, so last question here. Have a quick look, pause for a few seconds, and then quickly set it up. Alright, so once again, as expected, we would be using this formula here. Y equals to a times b raised to the power of t over p. Quickly plug the numbers in and see if you can work out this question or not. So Once again, the question is talking about the future population. So in this case, we are talking about a population of 17 years later, just like the last question. All right. So, all right, let's plug the numbers in. A, my initial population is 8,980. You can put brackets around or not, that's totally fine. So B in this case, hope none of you put down 13 here. So divided by 100, that gives you 0.13. Some of you may say, just like the last question, 1.13. Does that make sense? Read the question again. So in this case, if you look at this, we are losing population at a rate of 13%. So what does that mean? So that means you can think of this as if we start off with 100 people losing 13%, how many people are still there for next year? You still have 87% remaining. So next year you have 87. So take this number, times it by 1 minus this, or 100 minus 13%. So you have 87% of the population remaining. So with that said, that means to find the population for the following year, you would take 0.87 because 87% of the population is still there. And then once you figure out this tricky part, the rest is same old, same old. The total time is 17 years. And then this growth factor happens every year. So that means your period for this event is 1. So quickly plug the numbers in. You should end up with 841. Again, there is context behind that, not just 841. So that means there will only be 841 people remaining in the town. Alright? So I hope you don't find this unit too bad. And these are the questions you can definitely try out. And if you have any questions, feel free to send me an email anytime, even over spring break. Don't stress yourself out. Enjoy your break, enjoy your time off. There's more to come. Alright, take care.